Okay, welcome to 5 Minutes for the 5. Here we go. We are looking at question number 1 from the year 2017. This was a calculator-based question. Question 1 and 2 is always a calculator question on the AP test now. And they give you this question where they tell you that a tank has a height of 10 feet, and they tell you the cross-sectional area of the tank, and select values for that area are given in this table. And what we're going to be trying to do here is answer some questions regarding that information. And here we go. Part A, they wanted you to use a left-hand sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. The thing that you should be cognizant of right away is anytime you're looking for volume of a tank and you know what the cross-sectional area is given by A of H, you can integrate the area to find the volume. So to get this party started, we are going to integrate A of H from 0 to 10, and they ask you to do that with a left Riemann sum. So in looking at the table, you want to be aware that the intervals are not equal. We're going to go from 0 to 2, 2 to 5, and then 5 to 10. So in setting up your answer here, on the first interval, the length of the interval is 2 units times 50.3, because that's the left y value, and then 3 units times 14.4, that's the left y value for the second interval, and then 5 times 6.5, because 6.5 is the left y value for the third interval. When you do that, you get 176.3 cubic feet. This question has kind of 3 points involved. The main 2 points are down here. If you did the correct Riemann sum, if you showed some version of this, you're going to score a point, and then you're going to get a point for the approximation, which is 176.3 feet cubed. Also, for the entire question, if you have the correct units in A, C, and D, they'll give you the 9th point in the question. So just be aware of that. All right, here we go. Part B. Does the approximation in Part A overestimate or underestimate the volume of the tank? And explain your reasoning. If you go back and read the original question, they told you that A of H is decreasing. And remember that anytime a function decreases, a left-hand Riemann sum is going to overestimate the value of the area under the curve. So for this question, we're going to state that since A of H is decreasing, a left-hand sum will over-approximate that integral. So 176.3 is definitely an over-approximation. That's worth 1 point. You want to make sure you state that you have an overestimate and give the correct reason. Part C, now they tell you that the area in square feet of the cross-section is going to be modeled by this new function, f of h. This question is essentially asking you to do the same thing as Part A, except now you're going to do it with a calculator using this function for f of h. So this is just plug it right into the calculator and get your answer, and you should have 101.325338 cubic feet. This is worth 2 points, 1 point for the integral, whether you write it as the integral of f of h or 1 point to actually put the function in, and then obviously having the limits integration from 0 to 10, and then 1 point for your answer. All right, last part of the question. This is a related rates question. Water is pumped into the tank, and they want to know how fast the volume is changing when the height is 5 feet. All right, a lot going on here. You don't need the table to answer this question because we're going to be using the function given to you in Part C. So the first thing is we know that at height 5, dH dt is 0.26 feet per minute. All right, again, pay attention to the units. They always tell you what your derivative is that you're going to be using. And then they want you to find dV dt at h equals 5. So to do that, we're going to need to take the derivative of this whole function with respect to time. All right, so that means we're going to be taking the derivative of this integral with respect to time, which means we're going to be doing some second fundamental theorem of calculus, and we're going to be doing where t is the variable that we're taking the derivative with respect to. So here we go. dV dt is going to end up being f of h times dH dt, because the derivative of the integral will undo the integral, but we want to make sure we multiply by the derivative of h to make sure we kind of complete the chain rule there. Remember to always be chaining whenever you're doing the derivative of an integral. And that's going to leave you with now f of 5 times 0.26, because 0.26 is the value of dH dt at h equals 5, so we're plugging that in for dH dt. And then f of 5, you're just going to compute that by plugging 5 into the function they gave you in the previous question. And when you do that, you should end up with 1.694419 cubic feet per minute. And there's your final answer there. So with that said, your breakdown of scoring, it was 2 points to find dV dt. As long as you do the chain rule and you're going to get f of h times dH dt, that's going to be the 2 point breakdown there. And then your final answer of 1.694 cubic feet per minute. All right, this has been 5 minutes for the 5. Have a great day.